Hello, hello. I'm here to tell you about how you can wire up this robot. I don't want to give it all away, but give you the gist. So to do it, you are going to need these parts. The two motors that come with your motor kit. That should be part of your robot. You have a decoupling capacitor. It just kind of like smooths out the voltage. Electrolytic, do not put it in backwards. That would be bad. And we've got this Arduino Nano, which is exactly the same as the Arduino Uno you've been using before, but just smaller form factor. And we have the L293D chip that you were using before with your Zoetrope project. And we've got a half-size breadboard, which we're going to assemble it all on. So first thing you want to do is you want to take your Nano, and you want to just plop it in across the gap here. So it's not going to be fully symmetrical, but that's fine. Stick it as close to the end as you can to leave room for other parts. And then we'll also plop in our L293D chip, taking care that we pay attention to what side the little indent's on, because that is important. It makes a big difference. Going on from here, first thing we want to do is power everything. So one thing I did not include is the battery pack. Oh, look, there it is. So we are going to want to wire one side of this, use one set of them for our 9-volt side and one set of them for our 5-volt side. Do not get confused about what is what, or bad things will happen. So here's some things we're going to want to do. We're going to take our battery pack and just power up the 9-volt side. So there's our 9-volt battery pack, really 6 AA's all hooked up. Notice red to the red line and black to the blue line. So now we've got our rails powered. Now, the only thing on the Arduino capable of handling the 9-volt from our battery pack is this VN pin. That lets you power your Arduino from a battery pack, and it's hooked up to a voltage regulator, which just downgrades the voltage to the 5 volts that the Arduino likes. So now we've hooked up our Arduino, it's being powered, the voltage regulator is handling it. We will not hook anything else up to this 9-volt positive rail on the Arduino, but we should hook up the ground. So now our ground is connected to the ground of it. So now this guy's powered. Now we should probably run a wire to these guys. It's going to be a little awkward because it's going across. You'd route it around or whatever. But we're going from the 5-volt pin, just like we were powering stuff from our 5-volt pin before, and we're going to do it to the opposite rail. So this will be our like nice, safe 5-volt rail. And we'll want to hook it up to ground too. We've got another ground on the Arduino right here, GND, and we will hook that up to our blue rail. So now all our things are powered. It's not a bad idea, even though it's effectively already done, to hook up our grounds together. That's allowed. Absolutely under no circumstances hook up the positive rails together, but you can and probably should hook up the grounds. So just a wire across there. So that's all our power stuff. Now everything is powered there. We should also power our L293D as we have done previously. So we will hook that up. Remember, this is the brain power thing, the thing just to the right of the indent. That's our VCC1. That takes the nice little 5 volts. So we're attaching it to the 5-volt side. And then here's our big heavy duty power side, our VCC2. And so we'll hook that up to our heavy duty power. This powers the brain of the L293D, so it needs nice gentle power, and this needs the big beefy power to power the motors. Now we should also hook up our grounds. Our grounds are our middle pins, so any of these guys we may as well hook up one to one side and one to the other. Even though since they're connected together it's kind of overkill, but whatever. Never a bad idea. And then we're going to take our little motors. We're going to hook one of them. They always go 3 from the edge. 3 from the edge is where you control the motor from. So hook up one of them, 3 from an edge. And hook up the other 3 from an edge. And so now the motor's getting powered. These ones that are 3 from an edge. See, 1, 2, 3. They should never touch the Arduino. They're what is supposed to power the motors. The whole point of this chip is we take our little pins from the Arduino and we use them to power our chip. Remember, each chip is designed to control 2 motors, and so we'll do the same thing for both sides. So again, 3 from an edge, 3 from an edge, and each side of the L293D is controlling 1 motor. So one side of the motors, 3 from the edge on one side, and one's, yeah, there, just 1 motor per side of the thing. Now at this point, one thing you should do is put in your polarized capacitor. Polarized means do not put it in backwards. So it should have a side that usually says like negative, 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 negative. So maybe you should put that in the ground side, the negative side, not the positive side, and then the other side goes positive. So you notice positive, negative. The negative side is usually well labeled. So I want to flip this sucker, because otherwise I'm going to put it in backwards. I guess we'll do that. That effectively flips it. And we'll put it in like that. So notice the negative to ground on our big 9-volt side, and that'll just smooth out our power for us, because the way we're going to control the speed of these motors is using the enable pin and pulse width modulating to it. Now, these guys are enable pins. So by pulse, like analog writing to them, we can control the effective power of the motor by turning it on and off again really fast and changing our duty cycle, which is just our percent of the time it's on. We're effectively like kind of changing the voltage, particularly with this here. Anyway, so to do that, all we got to do is find a pulse width modulation capable pin, but we don't get our little squiggles here. Fortunately, this is exactly the same as any other, as the Uno we are used to. So if you see the squiggle on the Uno, it's the same squiggle here. It's just labeled D9 for digital 9 or digital 10. If you ever want to look something out, looking up something called a pinout diagram is always useful. So this is the nano pinout diagram. These are like your digital input-output pins, like your usual ones. You got your analog pins, your A0 through A1 or A7, all that goodness. A reset one, various powers, but yeah, these PWM ones are the one you're interested in. And notice, just like the Arduino Uno, pins 9, 10, and 11 are capable of PWM. Those are often the ones I use because they're easy to remember because they're all in a row. But also notice 3 works, and so does 5 and 6. So pick 2, any 2. Doesn't matter, just remember what they are. Write it down somewhere to control your motor speed. One's going to control the speed of your left motor, one's going to control the speed of your right. And you should probably know which is which. So anyway, here you go, pick one. Remember that is 3, 5, 6, or 9, 10, 11. And hook it up to one of your enable pins. So notice I'm just doing name of the chip and writing pin out, and that pretty easily gets me a thing. So the little indent would be up top here. Notice our like brain power is here, and here's our like motor power, just like we have it. Our outputs are going to the motor. So out 1 and out 2 go to one motor, out 3 and out 4 go to the other motor. Our enable pins are kind of like opposite corners, and they're opposite the voltage ones. So top left, if looking at it with the indent up, is the enable pin for this side, and then bottom right with the indent up is the enable pin for the other side. So wire them out to one of your enable pins, one to control the speed to one side and one to control the speed to the other. And then pick 2 other Arduino pins. So I might show you one side, but you could just do exactly the same as the Zoetrope. I'm gonna pick 9. I'm gonna wire up this side. This is my enable pin. Notice top left, if we're looking at the indent, the other one would be right down here. And so I'm going to use 9 to control its speed. And I'm going to pick 2 other pins that I'm not using for analog write. I don't know, let's say 2 and 3. Even though 3 is analog write capable, it'll still work. And I'll hook 1 to here, second from an edge. And I'll hook 1 here, second from an edge. It's getting a little harder to read, but hopefully you can see it. I've got pins 2 and 3 wired up to the things 2 from an edge. And so by setting digital writing one of them high and one of them low, I'll make the motor spin in one direction. And then if I switch which one's high and which one's low, it'll spin in the other direction, like change directions. If I have them both high, like this guy high and this guy high, it'll do nothing. If I have them both low, it'll do nothing, because there's no incentive for the electrons to move from one place to another, because they're at the same voltage levels. If you want them to move from one place to another, you need to give a voltage difference. By the way, if this second from this edge is high, like 5 volts from the Arduino, then that'll make this one, third from that edge, like big motor power. In this case, 9 volts with way more current. And if you were to make this one second from the edge, like if you were to digital write low to pin 3 here, it would go through the wires and connect this little pin to ground, so little weak ground, and then that would make the thing third from an edge here, big mighty ground. So yeah, by just setting one of these pins to high and one of these pins to low, you'll control the direction, and then you will analog write to, let me just, can't move the wire, whatever. You'll analog write to pin 9 or whatever you decide to use. Any of your analog write capable pins will do. Go into here, which is our enable. By doing that, we will control the speed. And analog writing, anything around 180, 200 is probably pretty good. 255, you might burn the motor out. You can test to see how it goes. Too low, it probably won't even turn. So play with that until you like it. And then do exactly the same thing to the other side. Take this guy here, hook it up to some analog write capable pin, which again is 9, 10, 11, 5, 6, and 3. So pick one, hook it up to this. You're going to analog write to it to control this guy's motor speed, and then pick another 2 pins you're not using, one to digital write high, one to digital write low to control the direction of this guy. And yeah, remember those go second from an edge. So pick some pin, say 7. And remember what all these are. So like It does precisely no good if you do not know what's connected to what. So maybe write it down or fully understand this. These two pins are controlling the right motor's direction. This one pin is controlling the right motor's speed, etc., etc. That's about it. Hopefully this makes it more clear. After you got that, make sure you use in your code to use pin mode on all the pins you happen to be using. They're all outputs, your digital writing or analog writing on all of them. So you want to take down that resistor shield so it gets a good amount of power through. And so yeah, pin mode them to output, and then digital write your two direction controlling ones, one high, one low, and analog write to your enable pin to control speed. So hopefully that makes sense. Thanks for listening.